6.5. We're going to be graphing tangent, cotangent, cosecant, and secant in this section. We're going to start with tangent and cotangent. If you have your unit circle readily available, get that out please so you can see where I am getting the graph of tangent from. And then off to the side I do have some notes that we will add to our foldable that will hopefully help making graph this easier. And if for those of you who already have stuff on your foldable, you might decide that you want to reword something, write something a different way that makes more sense to you, or you might hear something or see something that you're like, oh, I didn't know that that's where that came from, and so you write that down. So please make sure you are pausing this as you go. You have no graphs in the notes. The notes were just blank, so you are going to need to be copying the graphs as I go. Feel free to pause whenever you need to. So tangent. Tangent is sine over cosine, so y over x. We should already have this on our unit circles though, which will make this a whole heck of a lot easier for us. So I'm going to start by going around the unit circle, and we're going to start at 0. And I want the tangent at 0. So that is 0 divided by 1, which is 0. So there's my first point. And if I look at my note over here, first point is always at 0. Well, the tangent at 0 will always be 0. Then I'm going to go to pi over 2. The tangent at pi over 2, excuse me, the tangent at pi over 2, well, that is 1 divided by 0. Well, that's undefined. And graphically, when I'm showing undefined, I'm going to put in an asymptote. Now I'm going to go to pi. The tangent at pi is 0. Again, this is from my unit circle. The tangent at 3 pi over 2, also undefined. I'm going to go backwards around the unit circle. At negative pi over 2, my tangent is also undefined. It's the same as 3 pi over 2. At pi, tangent is 0. I forgot 2 pi over here. The tangent was 0. At 3 pi over 2, the tangent is undefined. That is the same as pi over 2. So another asymptote. And at negative 2 pi, the tangent is 0. So I have some points here. And let's see. I think I need some more. What is between 0 and pi over 2? Pi over 4. So look at pi over 4, please. The tangent at pi over 4 is root 2 over 2 divided by root 2 over 2. That gives us 1. I'm going to go to negative pi over 4, and the tangent is negative 1. I could plot some more points. I could plug in more values for x. My graph is going to have a curve very similar to what you guys would probably all quickly say, oh, that's a cubic graph. Very, very similar to that. If I continue to go through all the points on the unit circle, here I have 3 pi over 4, which is negative 1. 5 pi over 4, positive 1. Here's another one. Each set of these curves is one cycle. If we remember, I'm going to add some notes here. If we remember from when we were talking about the periodicity, I can never say that word. How periodic tangent and cotangent, sine and cosine are. Sine and cosine are periodic every 2 pi. Tangent and cotangent are periodic every pi. So here our amplitude is 1. There's a coefficient of 1. And that's my main point as I'm going around this circle. It is 1. It's going to change as my radius changes of the circle, but my amplitude is 1. And the period is pi. Each tangent cycle lasts 1 pi. So the formula for finding, or a nice little thing that'll help me find the period of tangent, is pi divided by omega, not 2 pi. So our very basic tangent graph will be amplitude times the tangent of omega x. Our starting point, still 0, 0. That happened in the middle of my period. Let me finish this real quick. Here's this one. Sorry, I need the points to make this more accurate. Let me put that there and halfway here. Put this one here. Okay, so there's a bunch of tangent cycles. From here to here, from negative pi over 2 to pi over 2, that's pi. And that is your period for a tangent. From negative pi over 2 to pi over 2. That is 1 cycle. Here's another pi, here's another pi, here's another pi, here's another pi. So my first point is always at 0. This is your main cycle right here. This guy right here, that's the main cycle. So from that 1 cycle, we can get everything else. First point's at 0. You split the period in half on both sides of the 0. So since my period was pi, I go to half and half. I'm going to show you more examples where your period is not always pi. So it won't be at half and half. It might be, if my period is 2 pi, half would be pi and pi. So that will change. You then put your asymptotes. So I'm going to make a note here. Split period in half on both sides of 0. Those are your asymptotes. And then for your amplitude, those were those extra points that I graphed. Here, I thought I changed my color. Here and here. That's your amplitude. Just like the sine and the cosine, we broke the graph into quarters, just like our circle is broken into 4 quarters with the quadrants. We have 0 and the asymptotes, which break it up into 2. You go to the middle and you go up. You go to the middle and you go down. So there is our tangent graph. So the up amplitude is on the right side and in the middle. Down amplitude is on the left side and then the middle. I was going to put a note for this and it just completely left my brain right now. So if I remember, I will come back and add that. We probably have already talked about whatever it was that I was going to say in class. Tangents are not that bad. Hopefully what I was going to say maybe will come up in one of the other examples. All right, let's do this next one. -3 tangent 1/2 pi. So before I start, I do need to identify my amplitude and my period. So my amplitude is going to come from the 3. Don't forget that negative is going to tell us that our graph is actually going to go down instead of up. Now I remember what I was going to have you guys write. Off to the side, if you have positive tangent, the graph is going to go up. Ugly graph. And if you have a negative tangent, your graph will go down. Something to keep in mind. All right. Back to this. Now we need to find our period. So my period is pi over omega because it's tangent. So it's pi over 1/2. Flip and multiply. So my period is 2 pi. Please watch. Watch how I'm going to graph this first. Then pause it, rewind, then go through and draw it and create it at the same time again. Watch first, please. You're going to miss something as you're looking down at your paper trying to draw. So tangent starts at 0. No matter what, tangent starts at 0. Now, if I look back at the notes, it says split period in half on both sides of 0. So my period is 2 pi. So split that in half. That's pi. That's where my asymptote is going to go. Asymptote, and then negative pi is the other asymptote. There's one cycle. I want to see a couple of cycles, you guys, with your tangent graphs. It just looks better. 3, 4 is nice. I do want to see at least 2. So I actually need to extend my graph a little bit more. From asymptote to asymptote is 2 pi. Well, if I'm at pi, 2 pi would be at 3 pi because I would have to add. Here would be 3 pi. That would be another asymptote, negative 3 pi. So 1 pi plus 2 pi, because that's your period, is 3 pi. So asymptote and 1, 2, 3, 4. 1, 2, 3, 4. Here's my other asymptote. Okay. So if you want to go ahead and pause it, this would be a good time to pause it. Maybe draw your own graph or just keep watching it. See how my zero's in the middle? In the middle of my asymptotes goes the other zeros. All right, now I need to graph my amplitude. My amplitude is 3. Now please watch, do not draw. Amplitude is 3, amplitude is 3. And when I draw this, my graph is going up. Shoot. Then I look back at my equation and it was a negative 3. So my amplitude I had backwards. My graph needs to go down. So I have to go on the right side, I actually have to go down 3. On the left side, I'm going to go up 3. So I'm going to do the same thing on the other cycles. Now I just need to draw in my tangent curve. So this one's going to be a little bit harder to draw because it's not as narrow. So it looks a lot flatter. It's really stretched out. Just do the best you can. Don't cross your asymptotes. There's the tangent graph with an amplitude of 3 with a negative flip over the x-axis and a period of 2 pi. All right, let's do one more tangent graph. I'm going to start with my period again and my amplitude. Amplitude is 2. Period. Pi over omega. My omega is 2. So my period is pi over 2. So this is a smaller period. So tangent starts at 0. Now what is half of pi over 2? Pi over 2 divided by 2 is pi over 4. That's your asymptotes. Your asymptotes are going to happen at pi over 4 and negative pi over 4. This is pi over 2. So pi over 4 actually happens in the middle. And then there's negative pi over 4. Okay, this is going to be super skinny. Let's finish putting the rest of our zeros and our asymptotes. So, your period is half of a pi. Your asymptotes occur at intervals of pi over 2, but when you include your zeros, they're at intervals of pi over 4, if you're going to use your zeros to help you with that. So this 0, sorry, well, let's do the 0. The 0's at 0. Then it's a quarter. Another quarter would make that a whole half of a pi. And then I would have asymptote in the middle. Asymptote in the middle. That's a half of a pi. Half of a pi. It just gets more and more sloppy. Sorry, you guys. Okay. Let me put some zeros in here. Okay, that's all I'm going to graph. Now let's do our amplitude. Amplitude is 2 and it is positive. So I'm going to go to the middle. Look at my cursor. I'm in the middle of the 0 and the asymptote and I go up to 2. In the middle of the 0 and the asymptote on the left side, down to 2. And there's your curve. Same thing here. Same thing on this side. Whoops. Sorry guys, I completely messed that one up. Wasn't even paying attention. Thought that one was too easy. Okay, there we go. I'm not going to look for anything perfect, you guys. As long as you know how to graph tangent, I'm happy. Identify amplitude and period and apply that to a graph, you'll be fine. So there's tangent. All right, let's move on to cotangent. That's all I have for tangent. Cotangent, when you use my unit circle again, cotangent we need to remember is now x over y. So if you don't have cotangent on your unit circle, that's where I'm getting this from. I keep dividing x by y, x by y, x by y. And I also have some extra notes here to help you graph this tangent graph when I'm done using the unit circle. So if I go to 0, the cotangent at 0 is 1 divided by 0, which is undefined. So there's my first asymptote. And look at my first note. First asymptote is at the origin. Now I go to pi over 2. At pi over 2, your cotangent is 0. It is 0 divided by 1. Go to pi, undefined. Oh look, second asymptote is at the end of the period. Well, just like tangent, cotangent has a period of pi over omega. And here my omega was 1. So my period is pi. Second asymptote is at the end of the period, pi. Now I'm going to put in my next 0. I go to 3 pi over 2, I get 0. I go to 2 pi, I get another undefined. Cotangent, just like tangent. Oh, I forgot to mention that before. Tangent is an odd function, so it's cotangent, so they are symmetric to the origin. So I'm going to flip this around. My asymptotes will be at the same spots. My zeros, same thing. You'll see the symmetry when we graph the actual curves. So zeros are in the middle of all of your asymptotes, so you can see that. Now, I'm going to continue to use my unit circle so you can see where I got these notes from. I need extra points here. Pi over 4. The cotangent at pi over 4 is 1. The cotangent at 3 pi over 4 is negative 1. So go up to the amplitude, then left to the middle. Go down to the amplitude, then right to the middle. So from your 0, that's what that means. From your 0, you go up to the amplitude, 1, then you go left. You go down the amplitude, then right. And you're going to do that for all of these. Always the middles, you guys. Cotangent is one of the easiest graphs that you guys will ever graph, I think. It's very straightforward. asymptote at 0, asymptote at the end of the period. And then you graph your amplitudes. Now here where this is different, positives go down. Okay, so if I have a positive cotangent, if I have a negative cotangent, those actually go up. So that is going to switch. All right, let's do a couple cotangents. Then we have to do some secants and cosecants. Actually, one of each. Here, my period and my amplitude. Amplitude is 3. Period is pi over 2. All right, here we go. Here's going to be another small one. First asymptote is at 0. Use these shortcuts, you guys. They're going to save you time. Otherwise, you need to be plugging in pi over 2, pi, 3 pi over 2, 2 pi, maybe some pi over 4s. You'd have to keep plugging those in for x and getting values. With cotangent, your first asymptote is at 0. Your next asymptote occurs where the period ends. So this is going to be your first asymptote. So I'm going to go to pi over 2, and there's an asymptote. Your 0 happens in the middle. Your period happens in the middle. Then your amplitude, you go to the amplitude left middle, to the amplitude right middle. There is your first cycle. Oh my gosh, this is going to be so hard to draw. Desmos will do this flawlessly. It's inhuman. It won't make errors. Now let's continue this. This 0 happened in the middle. So here's the next middle. Here's the next asymptote. I'm going to do a couple on this side too, and then we'll call this one done. 0, 0. Up, left, down, right. Up, left, down, right. Always to the middles, you guys. If this was too fast for you, you need to stop it and start it over. Pause when you're writing things down, you guys. Sorry, the curves are weird. It's so hard to draw the curves. So hard with that amplitude being so high. All right, let's look at this last cotangent. Amplitude is 1. That negative, don't forget, it's going to tell your graph, is not going to go down this time. Your graph is actually going to go up. Be careful. Period. Pi over 2/3. Flip and multiply. So this is pi times 3 over 2. So we have 3 pi over 2. There's your period. So I start with an asymptote at 0. My other asymptote happens at 3 pi over 2. Here's 3 pi over 2. That negative is not supposed to be there. There it goes. There's your 3 pi over 2. Pi over 2, pi. 3 pi over 2, 2 pi. So my other asymptote for the second cycle will be at negative 3 pi over 2. Now please watch. Your 0 happens in the middle. So I find the middle. From there, you apply your amplitude, which is 1. So it's going to be up 1, right to the middle. We need to find the middle. Down 1, find the middle. You're eyeballing it. Negative cotangent goes in the upward direction. So I know it looks kind of like, but it's a negative. It's just the way cotangent works, you guys. The signs change the direction of your graph. Middle, up 1, over to the middle. Back to the 0, down 1, over to the middle. Oh my gosh, I made that mistake. I just told you guys not to. See, it happens. There we go. All right, that takes care of cotangent. These do continue. They keep going and going and going. I at least want to see 2 cycles, so make sure you guys do draw 2 cycles on your practice problems. I know this is a long video. Cosecant and secant actually go very, very fast. All right, I probably have about 5 more minutes left, maybe more, because I still need to do example 2 with you. Okay, secant. Secant goes with cosine. So to graph secant, you must graph a cosine graph first. That is an absolute must. So cosine graph starts at 1. Its period is 2 pi. So you start and end at the amplitude. Halfway through, you're at your opposite amplitude. And then we have our zeros that happen in the middle. This is a very quick cosine graph. This is why we went over cosine graphs already. If you haven't practiced your cosine graphs, you need to, because this is going to be very complicated if you haven't. Okay, so I'm drawing my cosine graph. Okay. I'm drawing cosine because it is the cofunction of secant. Now, secant should also be on your unit circle, and so should cosecant. If they are not there, you're actually making this more work for yourself. And I would like you to go to these values of, excuse me, you can look at your secant values and your cosecant values as you go around the unit circle. And when you get there, you will see that these values are undefined at certain spots. Secant and cosecant have undefined values. And secant's first undefined value happens at pi over 2. So I need to put an asymptote. Its next undefined value happens at 3 pi over 2. So that spot gets an asymptote. And then I'm going to duplicate that on the negative side. So you can see that you have zeros. All of your cosine zeros just became asymptotes. That happens because x is 0. And cosecant is 1 over x. That makes those undefined values. All of those are undefined, so they need asymptotes. And then if you look at the rest of your secant values, all of those values are greater than 1. And they are less than negative 1. All of this here where the cosine graph is, that stuff does not exist on the secant graph. But they do start from 1 and negative 1. As we continue to go around the unit circle, we do have secant values of 1 and negative 1. And they actually happen at 2 pi, pi, 0, negative pi, 2 pi. And they continue to go and go and go. If I were to plot other points, I would see that I have values that make my graph actually curve away from the cosine graph. This is your secant graph. You need your asymptotes. The red is the actual graph. This is your secant of x graph. Now let's say I had a 2 secant of 4x. You would actually graph 2 cosine of 4x first. Then you would apply the asymptotes at the zeros, and then you would draw your curves away from the cosine graph. Graphing the cosecant is the exact same. you must graph the sine graph first. Sine starts at 0. Its period is 2 pi. It ends at 0. Pi is also 0. Amplitude is 1. Symmetric to the origin. So I use that to help me finish the graph of sine. You get the sine graph in here. Again, if you haven't graphed sine and cosine yet, you need to if you haven't done those practice problems. Now, if you look at your unit circle for the undefined values of cosecant, those actually happen where sine is 0, because cosecant is 1 over y. So anywhere y is 0, which is the sine value, you will have asymptotes. This is 1 over y. You cannot have 0 in the denominator. It is undefined. And for the same reasons as the secant graph went away from cosine, cosecant will go away from the sine graph. So you have your 1 there, go away from this everything in between 1 and negative 1. Again, we could be plugging values in for x. I could keep going around and around and around my unit circle, keep plugging in those values, keep checking them on my unit circle guesstimate about where those would be, and I could be plotting those points. So this is just a major shortcut. And just like with the the cosine and secant, when you're given cosecant, I can have a negative 2. That's an ugly C. Negative 2 cosecant of 2x. And you would want to graph negative 2 sine of 2x first, and then apply the asymptotes and move the graph away from your sine graph. So same thing, if you need to add anything to your unit circle, if you need to add anything to your foldable, please do so. Let's get this last example done, and I'm really just going to talk you through this. Find the average rate of change from 0 to pi over 6. And they're telling you the formula for average rate of change, which is slope. And they're telling you that f of x is the cosine graph. So I have the cosine graph. Here's my cosine graph. And what it's asking for, here's my coordinate plane, something like that. It's asking for you just to find the slope for a very small section. So from 0 to pi over 6. So that might be, let's say 0, and let's say this is pi over 6. It's just asking, actually it would be more like this would be pi over 6. It's just asking for like this little tiny piece. What is the average rate of change? It's not slope because it's not a line, but how fast is that little piece changing? So we do have something similar to the slope formula. So f of b, where you're starting from, 0 is your a, b is your pi over 6. So f of b, f of x is your cosine. So f of b cosine pi over 6 minus f of a cosine of 0. Those are your a and your b, divided by pi over 6 minus 0. So from here, you're going to use your unit circle to find those two values. So the cosine at pi over 6 is root 3 over 2. The cosine at 0 is 1. You need a common denominator. So 1 becomes 2 over 2. You can't combine root 3 and 2 because 2 is not in a square root, but then you'd still need a common root, and they're not. So I just show this as root 3 minus 2 all over 2, your common denominator. Pi over 6 minus 0 is just pi over 6. So that's still my main denominator. So I am going to multiply by the reciprocal. So 6 over pi, 2 goes into 6 3 times. I'm not going to worry about distributing, but you can. I just left it as 3 times, all of 3 root 3 minus 2, and then it's all over pi. That is your average rate of change. Sometimes you might see this as 3 over pi and then all of it times root 3 minus 2. That might be another way that might be seen. All right, that wraps up 6.5. I know that was an extremely long video and I apologize for that. If you need to watch it again, feel free, just watch what you need to. And please come to class tomorrow with any questions that you have.